All right, welcome everyone, and thank you for joining today's webinar. My name is Candace, and I will be your moderator. I have some great speakers lined up to talk to you about the new green infrastructure requirement and a stellar resource to help developers learn more about them. Speaking of developers, let's find out who we have in the audience as a few folks join us. All right, great. Thanks for filling out that poll. Looks like we have mostly engineers in the room. All right, so let's go ahead and get started. During today's webinar, we will cover three main topics. First, key changes to NJDEP's stormwater rules. Second, how to use the newly updated Developers Green Infrastructure Guide. Third, strategies for overcoming challenging site conditions with green infrastructure. And lastly, we'll end with an extended Q&A session with the panel from 1 to 1:30. If you have a question for the panel, please send them in the Q&A box at the bottom of your screen. Everything you see today, including the slides and the recording of the webinar, will be made available to you. We hope to have time before the hour is up for questions, but we have an extra half an hour of extended Q&A either way. I invite you to stay on if you can for that. New Jersey Future envisions healthy places for New Jerseyans to live, work, and play, where communities have safe streets and clean waterways that are free from flooding. Many communities in our state struggle with these issues. Thankfully, green infrastructure is a powerful tool that can help prevent water pollution and reduce flooding, while also delivering multiple economic and societal benefits, like cleaning and cooling the air and increasing foot traffic and pedestrian safety in downtowns. Our goal is to mainstream green infrastructure as a best practice in New Jersey, but we know this important paradigm shift cannot happen without the builders, and that a partnership with that sector is key. We learned from the builders how the old regulations discouraged green infrastructure, and then we worked with the builders and their professionals, environmental partners, and the New Jersey Department of Environmental Protection to craft a new approach, the newly amended stormwater rules, which we are excited to tell you more about. Now, I want to invite a trusted partner and leader in the development world who has become an ambassador for green infrastructure, George Vallone from Hoboken Brownstone Company, who will say a few words now. Take it away, George.
Today, on behalf of the Developers Green Infrastructure Task Force. This is a partnership between New Jersey Future and the New Jersey Builders Association. As past president of NJBA, I am co-chair of the task force, along with my friend and colleague Pete Kasbach from New Jersey Future. This task force was established to help New Jersey developers and our engineers learn about green infrastructure, understand its costs and benefits, and get a clear sense of its impact on the bottom line. One problem we knew needed solving was the state's stormwater rules. Without going into the gory details, the rules as currently written were very subjective. They were interpreted differently by different designers and reviewers, and that translated into costly delays and, frankly, very ineffective and inconsistent regulations. Working together with New Jersey Future within a stakeholder process led by the New Jersey Department of Environmental Protection, we brought a very wide range of interested parties to the table. The builders supported the green infrastructure rule change because it was an objective design standard which will not only improve water quality and help prevent flooding, it will also make the review and permit process more predictable, and developers alike predictability. Also, very importantly, our customer market and our neighbors want to see green infrastructure. And that driver, combined with predictability in the stormwater permit process, is what aligns this new green infrastructure requirement with our bottom line. We know it will be good for the people, good for the planet, and good for our profit. A true triple P win-win-win. That was clearly a result of this collaboration. I'm proud of the productive role the task force played in forging consensus and getting these new rules adopted. So thanks again for your interest. Come get a copy of the Green Infrastructure Guide at the Atlantic Builders Conference scheduled for September 29th to October 1st at Harrah's in Atlantic City. Now I'm going to pass the baton on to Jim Murphy. Jim is a supervising environmental engineer in the Stormwater Management Unit, which is a part of the Bureau of Non-Point Pollution Control in the Division of Water Quality at the New Jersey Department of Environmental Protection. Jim will tell you what to expect as the new requirements are implemented. I'd like to thank Jim and the DEP for convening the countless meetings and coordinating a long and detailed process, navigating opinions, agendas, politics, and God knows what else that culminated in the adoption of this new rule amendment. Here's Jim Murphy.
I appreciate that intro. First, I'd like to thank New Jersey Future and the NJBA for the opportunity to present today and talk about some of the key components to the department's adopted amendments to the stormwater rule under 7:8. I would like to add that these rule changes were made with significant amount of stakeholder input, including many of the panelists that we have here today, and not to mention NJ Future and the NJBA. Given the limited time we have, I'm going to just cover three key topics. I'll touch on the interim activities, give you an update on the BMP, and lastly, I'll address future training opportunities. Key changes under the rule include new definitions and changes to existing definitions. In particular, I'll address the green infrastructure and major development definitions. I'll talk about the green infrastructure standard and address how the applicability of the water quality standard is going to change. Remember, under this rule, there is no change to the standard. This rule replaces the requirement to use non-structural management strategies to the maximum extent practicable to meet groundwater recharge standard, stormwater runoff quantity standards, and stormwater runoff quality standards, with the requirement to use green infrastructure to meet those same standards. So while the standards are not changed, how you go about meeting them has changed. I'll start off with the green infrastructure definition noted under subchapter 1.2 of the stormwater management rules. In addition to the criteria listed, part of the definition specifies that green infrastructure manages stormwater close to its source. So don't overlook that phrase, as it plays an important part in this rule. Along with the BMP being close to its source, green infrastructure obviously has to treat stormwater runoff or store it for reuse. Other changes in section 1.2 of the rule, including adding regulated motor vehicle surface and adding the basis, and I'll touch on that basis for a little bit, plus adding a definition for regulated impervious surface. Lastly, as you can see in the slide, we've changed the definition of major development in an effort to more clearly express what activities are taken into account in determining if a proposed development ultimately causes impacts equal to or greater than the threshold established in the definition. Defining these new terms is intended to better describe those activities that have impacts that are intended to be subject to review under the stormwater management rules. The department incorporated into the new definition the specific time frame within which prior development must be considered in conjunction with the proposed new development to determine the ultimate impact of the development. The dates are now clearly specified within the definition in an effort to cut down on attempts to circumvent regulation by phasing or dividing projects into pieces that individually are below the threshold of major development. As I mentioned, we are not changing the standards, just how the water quality standard is applied. Since motor vehicles are a significant source of suspended solids, water quality applies to the impervious surfaces constructed for these vehicles, and this is consistent with how water quality was triggered in the past. Roofs and sidewalks still need to be accounted for in terms of quantity and recharge, but not in terms of quality. Again, the motor vehicle surface term has been incorporated into the definition of major development. The rules now require that green infrastructure be used to address the requirements for groundwater recharge, quantity control, and water quality. Subsection 5.3 of the rules includes 3 tables and lists the BMPs from the New Jersey BMP manual that may be used to meet the standards. The tables specify how information on each BMP may be used. Since green infrastructure must be located close to its source and treat or store runoff for reuse, some of these BMPs have an explicit drainage area limitation stated, where the design has an aspect that limits how much runoff it can treat or store. Municipalities will still have the ability to approve other designs, but those designs must match the green infrastructure definition and follow other limitations. Here you can see table 5.1 from the rule, which includes the green infrastructure BMPs. All the tables show columns indicating whether a BMP can be used to address water quality, quantity control, or groundwater recharge. The last column is the clearance required for the seasonal high water table, assuming the soil testing procedure in new Chapter 12 of the BMP manual has been followed correctly. I'll note that the Chapter BMP was formerly noted as Appendix E in the BMP manual. Some of these BMPs cannot receive runoff from vehicle surfaces and therefore do not address water quality, like cisterns and green roofs. Others do not attenuate the discharge of stormwater runoff from larger design storms, so they cannot meet the quantity control requirement, like dry wells. There are even certain manufactured treatment devices, or MTDs, that have a vegetative or soil component that meet the green infrastructure definition. Note that not all MTDs are considered green infrastructure. Lastly, these small-scale systems noted here have a limited drainage area that they can treat. Here's table 5.2 showing the BMPs that can be used to address stormwater runoff quantity control. These have drainage areas that are a bit larger or typically located a bit further from the source of the runoff and may only be used to meet the water quality and recharge if a waiver is granted. The BMPs in table 5.3 always require a waiver or variance before they can be used. It's not anticipated they will be used much in the future because of what is required in order to grant a waiver or approve a variance. Blue roofs don't have a reuse component, and extended detention basins are typically large and require additional treatment to meet water quality standards. The bulk of the MTDs do not have a soil or vegetative component, so they fall into this table. And we don't see many subsurface gravel wetlands or wet ponds, as wet ponds have a 20-acre minimum drainage area requirement with no reuse component. So just a few things to remember under the newly adopted rule amendments. Prior disturbance since 2004 and on, in combination with any newly planned disturbance, may cause the project to be considered a major development and subject to the standards. Green infrastructure is required to be used, and stormwater runoff must be treated close to its source. For water quality, it's motor vehicle surfaces and not impervious surfaces under the modified definition. You can see the rule proposal and the rule adoption document, which includes the response to comments. You can take a look at the web link that's noted there to find these documents. One aspect of the rule is that it has a 1-year delayed operative date and does not become effective until March 2nd of 2021. In terms of development, there are grandfathering provisions specified within subsection 1.6b of 7:8. These provisions address both local approvals and, where needed, department approvals in terms of what can be grandfathered in under the old version of the rules. I can't go through each aspect, but one component to be grandfathered would be to have a preliminary or final site plan approval from the municipality. And if you need a department permit, you must have submitted a technically complete permit application to the DEP before the March 2nd, 2021 timeframe. For more information on the provisos, take a look at 1.6 under the new rule. In terms of activities, At the municipal level, municipalities have been notified by the department that their stormwater control ordinances, or SCOs, must be updated consistent with the amended rule. The department has already completed and posted an updated model SCO on its webpage, and that's available for municipalities to use. Also note, as required under their MS4 permit, a municipality is required to post its SCO to its webpage, so you should be able to view the SCOs on those municipality web pages. In terms of the BMP manual, the department's comment period on subchapters 5 and 12 recently closed on May 1st, and we're in the process of reviewing the comments and making changes as appropriate to those chapters. The final versions of chapter 5 and 12 will be posted probably before the end of June. As you can see in the slide, some chapters were recently finalized and we posted to the department's webpage. Chapter 13 relative to the groundwater impacts, as well as the updated model SCO under Appendix D, were recently posted. Continuing with the BMP manual changes and updates, we are still working on edits and updates to chapters 3, 4, 9, 10, and 11, as noted. And once those chapters have been updated and finalized, or updated, at least, will be publish them on the web link that's noted there. Just a note, if we're not making significant changes, they will not go out for comment. If we make substantive changes and significant changes to those chapters, they'll be available for public input. In terms of training, the DEP is still planning to have its 2-day designer review training course. This course was originally scheduled for May, but obviously had to be postponed. It's been rescheduled to July for now, so stay tuned on any possible date changes for this training. In terms of that training, the July training will still focus on the rule prior to amendments, but we're planning on that same training in the fall to include and incorporate information relative to project reviews and the impact of the March 2020 rule adoption on those reviews. So keep an eye out on the webpage noted for updates on all stormwater-related training events and information. So that's a quick, brief overview of some of the key points in the rule, but certainly there are more changes I could not cover. I would encourage those listening to the webinar to review the rule, take a look at the rule proposal document, the rule adoption document, and even the response to comments to better understand the changes under this amendment. Don't hesitate to contact me or the department if you have questions in the future. Again, thanks to NJ Future and NJBA for the opportunity to present today. Thank you.
Thanks for that valuable information, Jim. If you have any questions at this point, don't worry. Go ahead and put your questions for the panel in the Q&A box at the bottom of your screen, and we'll pick them up at the end. At this time, I want to introduce our next two speakers, Ed Confair, an engineer and landscape architect at ENLP Associates, and Jeremy Lang, an engineer at Mazer Consulting. Both Ed and Jeremy were a part of the consultant team who helped New Jersey Future and the Builders Association create the Developers Green Infrastructure Guide, a resource to learn more about how to apply the new rules that you just learned about from Jim. First, Ed is going to tell us more about the guide, and then next Jeremy will talk to us about challenging site designs with green infrastructure. All right, take it away, Ed.
I'm excited to be here today with everyone. As Candace said, my name is Ed Confair. I'm the Senior Program Manager for Resiliency with ENLP Associates. As both a professional engineer and landscape architect, integrating green infrastructure into site design is something that is near and dear to my heart. So it's very lucky to be involved with this team, with Candace, Jeremy, Jim, George, and so many others to get this new guide off the ground. We're very excited to be here sharing it with you today. So as we look at the first slide, this is version 2.0. The guide has been in existence for a few years now. I think I speak for everyone on our team when we're excited to unveil all the updates today. It seemed very appropriate to readdress the guide this year, knowing that the culmination of all the background work with NJBA that George mentioned at the top of the presentation was coming to fruition. And so there is both an online web version of this guide and a print version. I'm going to cover aspects of both here today in this section of the presentation. So starting off with what's the purpose of this guide? First and foremost, this guide is for developers working in the state of New Jersey. You're the target audience, and the guide is meant to help you understand and navigate the new rule adoption, as well as upcoming changes to the companion BMP manual. Even for developers and engineers familiar with operating under the old rules, there was nuance and room for interpretation that exists under the new rules. We want to give the development community as much of a head start as possible on adapting and thriving under the new rules. Two, we want to illustrate how the new rule is a positive change from the current status quo. I know I have things about my routine and way of working which are set, and it can be hard to integrate new ways of designing or thinking. We want to highlight the positives to be gained by this change in the upcoming slides. Three, I want to highlight common practices which we're all used to, which have been removed, and the benefits to be gained by their removal and the practices that should replace them. Building on this last point, I want to show you a couple of things that are in and a couple of things that are out. So first, gray and exclusively end-of-pipe stormwater basins. I think we're all used to the practice of cordoning off a section of our sites, whether it's commercial, subdivision, mixed use, and identifying it to be our big end-of-pipe stormwater storage place. Under the new rules, what's in is a decentralized approach to green infrastructure. The benefit to be gained by this is more efficient systems with potential for greater project yield. And I know who's going to argue with the potential of getting an extra lot or more developable area on a project site. Another thing that's out, redundancy in engineering calculations. What I mean by this is we're required as engineers to assume that certain natural processes such as infiltration either don't occur or will fail at some point. This results in over-designed stormwater systems. So what's in, as part of the BMP manual updates, is that infiltration will count. The benefit of this is that smaller, more accurately sized systems save on construction costs and increase developable area. And again, who's going to say no to reduced upfront hard costs? Finally, you heard Jim mention this. You'll hear Jeremy, myself, and others mention it further before the end of the presentation today. The maximum extent practicable nature of the non-structural regulations of the rule are being replaced with the more objective mathematical standards in tables 5.1, 5.2, and 5.3 that Jim gave the overview on. The benefit of this is a more predictable and efficient permitting and approval process. We all know that time is money, and who's going to say no to better predictability? So moving into the guide itself, as I mentioned, there is a print guide and there's a website. You see the website homepage on the screen now. We've included 2 feature buttons front and center to learn about the new rule and another to download a PDF of the guide. We've also included the most important components of the guide along the header at the top of the webpage for convenience. Structurally, the guide is broken down into 8 main chapters. I'm going to focus on the first 3 in subsequent slides, but I do want to give a brief overview of what's in each first. So the first one, the New Jersey rules and requirements. Jim just went through this. We're going to highlight a couple key pieces of this section in a few moments. Section 2 is the largest section in the guide. It covers types of green infrastructure. This is a high-level overview of different BMPs included in tables 5.1, 5.2, and 5.3. And it also includes a new decision-making tool that we've developed to help identify which ones are best for any given project. And we'll have more on this in a moment as well. Third, there's a pre-rule versus post-rule comparison chapter. We believe this is an important section in the guide as it highlights real projects with tangible benefits to be gained through the application of the new rule. Addressing challenges and solving problems. If anyone's working on a brownfield site, a site with low infiltration, or other site constraints that you feel make it difficult to adopt green infrastructure, this chapter is the one for you. Case studies. Green infrastructure has been done before in New Jersey and to great effect. We've highlighted examples of several different types of developments. Each study highlights not only the design summary, but the decision-making process, challenges encountered, and approach to maintenance. One thing you'll notice in all of the case studies, and it's a point that's specifically reiterated throughout the guide, is the iterative, integrated, and comprehensive design process these projects went through. Affecting the most positive change through green infrastructure design requires thorough planning with all parties at the table from the beginning of the development process. The successful projects we're showing in the guide and the side-by-side comparison chapters all have this approach. The benefits of green infrastructure section looks at the financial, community, and environmental benefits of green infrastructure. The FAQ section, in conjunction with the addressing challenges and solving problems chapter, we feel addresses all of the typical issues or questions we frequently hear about the application of green infrastructure. If you have questions on maintenance or mosquito breeding, you should come here. And finally, we have an extensive resource list. The guide frequently references resources for further reading, and all those references are captured here. So chapter 1, the New Jersey Stormwater Rules and Regulations. Again, I'm not going to belabor this too much since Jim covered it very thoroughly. Just want to give a few takeaways on what you'll see on the webpage when you visit it. So when you click that key feature button on the homepage, it'll bring you here. And we'll have a high-level overview. You'll notice in bold, we highlight important things like the operative dates that Jim mentioned. And then as you scroll down the webpage, you'll see that we highlight tables 5.1, 5.2, and 5.3 with overviews, and then again, key buttons in blue below that for further reading. Moving further into the guide, the types of green infrastructure chapter. Specifically, I want to go over the decision-making tool we've developed to help navigate the requirements of the BMP selection tables. So you'll see here, this is the print version if you download the PDF. There's a full page spread given to help you navigate the various decisions that either you as a developer or your design professionals will have to evaluate during the project. As I'm sure you could tell from Jim's explanation, there's a lot to digest with the new tables and how to apply them effectively on a project-by-project basis. I certainly don't expect everyone listening to digest everything they're seeing on the screen right now in one pass. But I do want to call your attention to its location in the guide and follow up with the web version of it, which is more interactive. This is also mobile friendly, so we're hoping it becomes a common tool that's put into use. You can see it initially prompts you to ask if you're a major development. Questions proceed based on that answer. In this case, if we answered yes to having more than a quarter acre of vehicular surface, it'll take us to the next question. I then answered no to being in any type of limiting zone like urban redevelopment sites or a site with no infiltration. Until the final display lets you know which BMPs are applicable to your project for quantity, quality, and recharge. You can even click on any one of those boxes as the BMP is listed, and you get a representative photo and description for more information. We hope that this tool is usable on the spot, in meetings, on your phone to gain a quick guidance on what options are available to you. Then you and your professionals can go to the BMP manual's appropriate chapter for further detailed technical guidance. The third chapter we're going to look at a little more closely here is the pre-rule change versus post-rule change side-by-side comparisons. We took real projects and we showed what they look like under the old rule and the new rule. We have several specific examples in the guide and on the webpage covering residential, commercial, and mixed-use projects. And we're looking at the commercial one on the screen right now. This is the print version. It's a straightforward side-by-side comparison, highlighting like items on the left under the old rule and how stormwater management becomes dispersed and decentralized under the new rule. Again, there's a web component to this that is more interactive. You'll see that there's a little slider arrow and line on the right side of this image. As that slider gets pulled to the left of the screen, it starts to reveal the application of green infrastructure on the site. You'll see that the large pink circle, which was just an end of pipe basin, is becoming replaced by several smaller pink rain gardens and blue pervious pavement areas. This increases the developable area on the site, which when you pull the slider all the way to the left, you can see in this case is a quick service restaurant highlighted in yellow. So this is an extra amenity added to the site, not possible under the old rule, and is now possible under the decentralized approach of green infrastructure. So these are just some of the examples that we've put throughout the guide. We've tried to address as many of these challenges as we could in the guide through these chapters as well as the additional 5. I just want to thank everyone again for having me. I'm Ed Confair with ENLP Associates. My contact info was up on the screen. And I'm now going to pass the baton to Jeremy Lang, who's going to do an even further deep dive into some of the more complex challenges I'm sure we're all thinking about as we're listening to these high-level overviews. So take it away, Jeremy.
Good afternoon, everybody. Thank you, Ed, for that introduction. I'm going to speak today regarding the common and perceived challenges associated with green infrastructure, as Ed mentioned. Us as design engineers, we often are tasked with basically fitting in green infrastructure or fitting in stormwater, really. At the same time, we're competing with developable space, whether that be yield or square footage for retail component or a warehouse project, whatever the case might be. So as a result of that, there are often these common and perceived challenges with green infrastructure. So you'll see here in the picture on the right represents an ideal green infrastructure situation. We've got plenty of room. We weren't constrained land area wise. It's not too deep. There's a wide variety of landscaping. So really a perfect situation. But while sometimes this happens, it often is not the case. We don't have that perfect setting. So there are several real world constraints that I'll go through, and these can include things like limited room or land area, shallow seasonal high water table, poor soils on the site, urban redevelopment, brownfields, and not having any kind of a receiving storm sewer or waterway. So let's start with limited room. Here's a site example where we capitalized on the limited room by using green infrastructure to almost create additional space. And we did that by having the green infrastructure serve in multiple capacities. So in this case, we created a multifamily cul-de-sac. So essentially the center of our cul-de-sac is the green infrastructure area. That enabled us to create more frontage along the cul-de-sac. So we actually have 3 buildings around this as opposed to 2. It also gave us a nice view shed. All these units kind of front this cul-de-sac. So now they've got a nice view shed to look at. Instead of just a big paved area with parking lot and garages, they've got this very attractive area to look at. And then finally, it's providing stormwater management. So the end of pipe system in this development is actually significantly smaller because of the infiltration we're able to achieve at this location. Green infrastructure can take many shapes and adapt to a specific site. So not only, in the example you're seeing here, but it can fill in leftover areas all over the site. That might take the form of parking lot islands in a commercial application. It could be filling in kind of irregularities created by property lines or easements on a site. And then other site constraints, such as freshwater wetlands or riparian zones. Basically all those leftover areas that aren't the nice squares or rectangles, we can fill those in with green infrastructure, stormwater management, and then reduce the end of pipe areas. This approach also works in roadside areas. So you'll see in this example here, we have an Oldcastle biomod system. It's a structural type of system, so it can be in a very narrow footprint. The actual specs for this even allow for the curb line to be right on the edge of the unit. So where you see the 2 kind of walls that define the mulched area, those could actually be curb lines. So it can be that narrow and compact depending on your needs. In this particular case, it's obviously fully structural, but it's also under-drained. We had some shallow groundwater here. So we under-drained the system, and we're getting the benefit of green infrastructure, even though we had a poor soil area. And just remember, I'll point out again that the more of these types of systems you can put throughout your site, the smaller your end of pipe system will be, which has the potential then to increase the site yield, whether that be the number of units or the amount of square footage of a commercial use. Next up are some other solutions for shallow groundwater and poor soils. This is kind of an innovative solution where we're using two green infrastructure methods in combination. So on the left here, you see this parking lot, but that's not just a plain old parking lot. That's actually got porous pavement in it. So there's obviously advantages to porous pavement, and I'll actually get into that a little bit more later. But one of the things we're doing here, we're not only getting the benefits of the porous pavement and the attenuation, but now as that water goes into the ground, it is actually migrating over into this constructed wetland that you see on the right side of the picture. So even though we have poor soils on the site and we weren't able to do infiltration, we were still able to use the porous pavement by using it as a feeder, basically a groundwater feeder, shallow groundwater feeder to supply the constructed wetlands. This worked out well, and as you can see, the wetlands is flourishing because we were able to keep a steadier supply of water. It wasn't just when it rained and we had that kind of immediate runoff from impervious surfaces. Rather, we had a more steady flow as it kind of leaches out of the shallow ground and supplies the vegetation. So when you've got a lot of water in a challenging area, there's a solution for that. And you'll see on this slide that solution is to work with nature and create a pond, or what we call a wet pond. This works great with shallow groundwater and poor soils as well. In fact, poor soils are arguably a plus. We generally line these ponds, but the poor soils kind of act as a plan B. This achieves more than just water quality and quantity attenuation. Even though it's not regulated, thermal impacts are actually dealt with a wet pond, because you're essentially cooling the runoff that's coming from your rooftops, your parking areas, which can be fairly warm, both by dilution in the pond itself, and then also with mechanical means, where you can have a decorative fountain, or if noise is a concern, you can have a bubbler like you see in the left side picture. This also allows for beneficial reuse of runoff for irrigation. Both of the ponds that you see in these pictures are actually also the primary water supply for the irrigation system. So they were designed to have a certain depth of water between the first positive outfall and where the turn on for a makeup well would occur. So the makeup well would only operate in periods of drought, but in most periods throughout the year, the volume, the storage volume between the first outfall and the turn on elevation for the makeup well, that volume of water is all, first of all, it's all stormwater runoff. And then second of all, it's the primary supply for the irrigation system. So a great combination of uses. In addition to all that, ponds are excellent in terms of being attractive. You can see here, we've done some very attractive native landscaping in the littoral zone. This obviously has less maintenance and is visually attractive, but it also discourages kids from coming too close to the water, and it discourages geese from using the pond. Nothing will stop geese, but geese prefer to have a shoreline where they can walk easily in and out of the water, and this type of vegetation precludes that. So often they will move on to a more suitable location. Another very flexible solution is porous pavement. This also works well in shallow groundwater and poor soils conditions. In a shallow groundwater condition, it works well because it's a relatively thin installation, and it is right at the ground surface. You don't need any depth. The BMP starts right at the paved surface. In terms of poor soils, they can be under drained, so you still get credit, obviously not for infiltration, but you would get the water quality and attenuation credit, which is very important. It still acts to reduce the end of pipe system size. Perhaps an unexpected benefit, and you can see this in the right photo, is it can reduce slip and falls and the need for de-icing chemicals to be applied. The reason for that is, as the snow melts, the water is going straight down into the porous pavement as opposed to running across the pavement surface where it can refreeze as black ice. Also, the air movement under the snow, because of the nature of the porous pavement, helps to melt the snow and ice much quicker. So these are just some additional benefits on an already very effective BMP. In urban redevelopment, bioretention, can be a very flexible solution. So a couple examples here where bioretention can be fit into parking lot islands, either in a very narrow configuration like you see on the left, or more on a perimeter in a wider configuration. This can be done as a focal point, whether that's for a sitting area or for outdoor restaurant seating, other types of amenities such as a bus shelter. You can integrate them in and, again, do double or triple duty. As you'll see in these photos, you can do it with or without curbing. In both of these, there's actually curbing, but in one case, it's a fully depressed curb, and they just use some wheel stops for delineation. That allows you to get more sheet flow in, and if you had erosion considerations, that might be a way to go. You can see in the photo on the left, there's actually a depressed curb, so you've got more concentrated inlets into it, and then it's distributed throughout the bioretention system. When you're concentrating a flow like that, you do have to pay attention to soil erosion. And you'll see the stone goes up to that depressed curb to address that. The key is, though, that these are very flexible. They can be done with and without under drains again. So if you have poor soils, it doesn't mean you can't use them. In terms of flexibility, the same is true for brownfield sites. GI will work very well on a brownfield site. The twist here is that you have to line it to separate it from any capped areas, and then you're often under draining those GIs as a result. Typically, we can't put water into the ground on a brownfield site. There are exceptions to that, so you would certainly work with your environmental professional to make those determinations. GI they would use on a brownfield site might include things like porous pavement, bioretention, wet ponds, or as pictured here, a constructed wetland. Of course, there are always challenges in stormwater design, so I invite you to post questions using the Q&A function at the bottom of your screen to ask those questions, and myself and the rest of the panel will endeavor to answer them and kind of maybe give you some ideas and some tips and tricks on how to take advantage of GI in a variety of situations. Speaking of challenges, I'm often asked how to have GI work on a warehouse project site. Warehousing can be tough for decentralized GI just due to the coverage intensity. There's obviously an enormous amount of rooftop, as well as truck loading docks, trailer parking, passenger vehicle parking. So it does make for tough and arguably maybe even the toughest application for GI, but it's far from impossible. Roof area is probably the most difficult thing to deal with just due to the sheer size of the roof and the generally a 2.5 acre drainage area limit for those table 5.2 BMPs that Jim went over earlier. So one of the several solutions to this is using underground roof recharge. This can take many forms. In this case, it's a Cupolex system underneath the loading docks. You're already doing a concrete pad in those areas anyway, so you're already building the roof, if you will. So it's really just the form work and then the additional concrete to create the pillars that you have to add, and of course the stone bed below. These are very effective for infiltration because you are getting a full, clear space volume as well as the stone volume voids underneath that. Some other alternatives, though, could include things like pervious concrete in the dolly pad areas or in the parking lot areas. It could include a perimeter bioretention. And this can be done in a couple different ways. It could be just literally a ring around the site, and then you provide some check dam separation to meet the drainage area requirements. It could also be breaks in trailer parking areas. They may line up with the man door accesses in the loading dock area. So you have a nice visual kind of synergy. And then finally, wet ponds are a great way to meet the rest of the quantity requirements in this type of development where you've got a very intense, large-scale development. Wet ponds work out well for several reasons. In addition to the more robust treatment that I described earlier, they can also allow your storm sewer system to drop down on the site and help limit fill, where you've got, generally speaking, pretty long runs because of the nature of the site. So I find wet ponds are a great complement to kind of pick up the slack from any water remaining not captured in bioretention or subsurface infiltration. Next is another sample project completed right here in New Jersey. This was in Mount Olive, New Jersey. It has a Cupolex system as well. This one's not under the loading docks. It's in a standalone area. This could easily be under a parking lot or under the trailer storage area, wherever the soils and the site layout makes sense. In the current warehouse market, this type The systems are very cost effective because you're allowing those circulation areas or parking areas to do double duty. And then you're decreasing the amount of end-of-pipe stormwater needed, which can often lead to an increase then in the gross floor area that's achievable. And in these industrial and warehouse uses, that per square foot price is very valuable, and it's only become more so in this COVID-19 world. Of course, the go-to GI approach for these sites is still bioretention. It's definitely the cheapest way to go, the most attractive. It's just a question of how much land area you have, how much of those irregular areas I spoke about earlier. So you want to try to use that, kind of use up all those leftover areas, and then whatever's left, you're going to use a combination of these subsurface systems and a wet pond type system at the remaining end of pipe. So at this point, I'm going to turn it back over to Candace to recap and wrap up.
Great. Thanks so much, Jeremy. So I want to thank all of our panelists for the information and great insights that they shared. So here's our contact info up on the screen now. Please feel free to contact us again if you have any questions, and we will make this webinar and the slides that you saw today available after today. So now I am super excited to announce the new Developers Green Infrastructure Guide. All right, so I'm excited to announce the new Developers Green Infrastructure Guide is now live. You will see the URL for the website in the Q&A box. So please go ahead and check it out, share it with your colleagues, and let us know what you think. So I want to thank all of our consultants, including our web consultant agency and the William Penn Foundation who helped to make this project possible. So this now concludes the presentation portion of this webinar, but I invite you all to stay on for our extended Q&A session from 1 to 1:30. So we have our full panel back. Let's roll straight into questions. So I have my colleague, Louise Wilson, who is behind the scenes, helping us out, queuing up and curating some questions for us. Louise has played a critical role in helping to develop the Developers Green Infrastructure Guide. So thanks so much, Louise. All right, so why don't you please pass some questions along to us at this point?
Okay, thanks, Candace. Can everybody hear me?
Yeah, we can hear you.
Good.
Yep.
Thumbs up. So we have lots of questions and probably more than we'll be able to get to in 35 minutes or whatever it is that we have. So I will, I'm going to obviously pose a lot of them, but the ones that we don't get to, we will answer and post both on our Green Infrastructure Guide 2.0 website and also in the form of a blog post, which everyone will receive. Candace mentioned the website going live, which is really exciting for us. I just want to give a shout out to agency, the consultant that really helped us to build that website, and they did a great job. So I'm going to get to these questions. There's a few that are in the same theme and have to do with the definition of major development and the looking back period. So I'm going to read one, which I think captures what all of them are trying to ask. In terms of history of development at a site, who is responsible for keeping track of this, as it can trigger a project being considered a major development? What if a property has gone through multiple owners? How can a municipality check on this to make sure that site history is being documented correctly? So I guess this is really a question for Jim from the DEP perspective, but also for the engineers who have, experience with this interaction with municipalities.
Right. So hopefully you can hear me okay. It's a great question. What we're looking to do in terms of consider the dates is, a lot of the development, whether it's major or not, still needs to go through the local municipality for review and in some cases approval. So it's what the municipality has on their books, what they're aware of, since a lot of these are obviously below the major development and don't need 5G3 permits because they're not above 1 acre. they don't need anything from the department. But we're going to rely on the municipalities. Municipalities have to do the review and approval of all the projects in their town. So it's what they're aware of, what they have on their books in terms of being able to coordinate past development since 2004 with new development that's planned.
So those dates, that follows the property as opposed to the owner. Is that correct?
That is correct.
Okay. Here's another question. Can townships require a project to comply with the new stormwater rules prior to the NJDEP effective date of March 2nd, even if the old rules are in effect for NJDEP? This is a question we've gotten a number of times. That's another one for you, Jim. What happens in the interim if a municipality has updated its ordinance to comply with the new rule, but DEP is still enforcing or has a set of expectations that relate to the current rule?
Right. So that's an interesting question. And we've always said the municipalities can be more stringent than the department's rules. So they can adopt, the department's definition of major development is 1 acre or more, and a quarter acre of impervious. So if some towns have adopted, let's say, 5,000 square feet of impervious surface under the old rule, and they were more stringent. I do anticipate that some municipalities, not most, if you will get a jump on it and have their local stormwater control ordinance updated before the March 2nd, 2021 deadline. So my understanding would be that you need to comply with the locals. If the locals are implementing that sooner, I believe that any development would have to comply with the local SCO. But that I will caveat that with it's a question we received in a webinar yesterday, and we're still kind of looking at what that final answer would be. But in my mind, if they've gone through the process, properly adopted the new standard, essentially they're being more stringent, then they can apply that standard. But we wanted to be respectful, and with the input we've gotten from all the stakeholders and particularly the builders, there was always that concern about having the ability to have projects in and not have to redesign them to meet the new standard. So we've put that 1 year delay in place so that the developers and the builders can understand what the requirements are and meet the design that is in place for that day. So I'm not sure how many municipalities will have something adopted by March 2nd, but I would say comply with what's on their books at the time, and I can do some follow-up on that to verify how that's going to be implemented.
Okay.
Louise, if I can just add to that,
Sure.
on residential projects, because they're controlled by the RSIS, the full 1 year operative delay will apply. So I would fully agree with Jim that relative to a commercial project, the local ordinance, once adopted, would take control. But on a residential project, because it's under the RSIS, and the RSIS refers to 7:8, which of course has the 1 year delay, it would not be applicable even locally on a residential project until it's effective next year.
Right.
Yeah,
so
thanks for
after March 2nd of 2021, RSIS will incorporate the new rule by reference. Is that correct?
Yes.
Yes.
Okay.
Mm-hmm.
That was a whole question in here. Here's another one. The pre and post sites, meaning pre-rule change, post-rule change, the side-by-sides, seem to rely heavily on pervious pavement. Typically, we find that pervious pavements fail due to them becoming clogged by salt, sand, and other snow treatments. Are there any sort of training initiatives being considered to ensure the long-term viability of pervious paving systems?
I can take a stab at that.
Go right ahead.
So first, I'm actually kind of surprised to hear that. We've done quite a few installations with porous pavement, the pavement itself is not actually the restricting factor. It's really the underlying soils. And generally the pavement catches all those, sand, salt, silt, whatever other debris. And that can be significantly compromised without actually diminishing the overall capacity of the system. So I've seen them where they're not maintained. In fact, I'm thinking of one in particular where I have a client that I know has not maintained it since 2007 when it was installed, and yet it's still working very well. It's actually on my way home, so I stop by every now and again. But to answer the question, as far as maintenance, there's two different things. One would be vacuuming, just a vac truck like you would see out in a commercial parking lot, picking up debris. That will help get all that sand and silt that's caught in the top layers up. And when a more robust treatment is needed, it can be jetted with high pressure water, and there's many contractors available to do this. You simply jet it over to one side, and then you simply vacuum up then the silt as it settles out of the water.
Quick follow-up about permeable pavement. What is the impact of freeze-thaw on the porous pavement?
That's another myth. There's a lot of speculation that freeze-thaw will adversely affect porous pavement. There are a number of university studies, and if you Google this, you'll find it on the web, that demonstrate that's not in fact the case. The reason for that is the void space in the system is creating a buffer essentially, so you're not getting that heaving action. And I've seen this in real life, again, having installed this in many projects, both residential, commercial, throughout New Jersey, which we're certainly experiencing freeze-thaw cycles. We're not seeing heaving or cracking in those systems.
Okay. Here are a couple of technical questions, and I think they're related to each other. So I'm going to ask them one after the other. And if I've misunderstood, you can just answer them separately. First is, how do you analyze all of the separated BMPs separately in HydroCAD? Is reduced CN method acceptable to NJDEP when they have jurisdiction or to local reviewers? And the second question is there any change for the K value? As it is now, the effective rate is cut in half and thus increases the footprint of infiltration systems. Are those questions sort of related, or did I, well, either way. Any of you technical experts that wants to jump in and answer, or starting with DEP about the CN method and that kind of thing?
Well, I'll do the best I can to answer these questions. I don't have, I have some familiarity with HydroCAD, but not probably as much as Jeremy or Ed. But in terms of the K value, there's no changes to any of those requirements or inputs that you would use. And then the other one was reduced CN values. Did I understand that right?
The question was, is reduced CN method acceptable to NJDEP?
Jim, I can handle that if you want.
Yeah, I'm not sure the context of how to answer that, though, because I'm not sure, are you looking at pre-development, post-development? But, Jeremy, go ahead, take it.
So what I think they're referring to, McEwen came up with a method called the reduced curve number method, and it's a way of accounting for green infrastructure without having to route it. So to the point, in HydroCAD, you have to route each BMP, and if you have a lot of decentralized BMPs, especially smaller ones, this can be quite tedious. So there is a simpler method, this reduced curve number method, and essentially what you're doing is you're taking the volume in that BMP and then dividing that over the land area and coming up with an effective curve number. So it's basically you're accounting for it by reducing the runoff curve number. I did confirm with the Water Resources Division at DEP that they will be accepting that. That was one of the comments that NJBA made on the draft BMP manual chapter. So I'm hoping to see that before they finalize Chapter 5, that they'll explicitly add it. But like I said, I did confirm they will be accepting it.
Yeah, so that's the McEwen method. And I believe you're right, Jeremy. We did receive a significant number of comments, and we have incorporated that into, I believe it's subchapter 5.
Okay, I have a question that probably George is a good person to answer. can you address cost or return on investment generally of green infrastructure BMPs? This could be to the engineers as well, but I'd like George to do it first. And then he goes on to say, or she, for instance, a lot of the hard infrastructure stormwater systems, like under parking retention, is very expensive. We're making arguments that just using GI to infiltrate will reduce need for these expensive systems, but we need more readily available information on cost savings to make the arguments. Also, savings on maintenance. Can you speak to that, George?
Sure. I think there's sort of tangible and intangible benefits, both financial. The tangible benefits are that you're basically changing from structural strategies to non-structural strategies, which basically means instead of building large bunkers for stormwater detention underneath buildings, because I'm an urban developer, we typically have to put our detention basins under the building because we don't have a lot of excess property beyond the footprint itself. And that is extremely expensive to do. So by replacing that with green infrastructure strategies where you can infiltrate, you're absolutely going to save money. And then from a maintenance standpoint, it's the same thing. You're basically having your landscapers maintain the system as opposed to engineers and plumbers and people that deal with structural systems. The intangible benefits that we've seen is public acceptance of what we're doing. Our market is 75% millennials, and they are very socially conscious. If they have a choice of 2 apartments to rent in 2 different buildings, equal in every other respect, but one shows a very robust green infrastructure profile, which means landscaping that has active uses to it, they appreciate that. And we put signage up around our sites. We have 2. The one site I'm thinking about, we just put online recently. We have 2 parks, one at either end of the property. We have a New Jersey Railroad easement from an abandoned rail line that we were allowed to landscape and give people the right to enjoy that passively. And we put signs up by our sidewalk swales. We've got some rain garden areas. We've got some mini detention basins. You might call them wet ponds, but they're really small. They're just inserted into large sidewalk areas. And we're educating people as to what the purpose of these installations are. They're not just pretty faces. They've actually got a very useful reason for being where they are and doing what they do. So those intangible benefits where people feel like they're living in a project that's socially conscious, I think are part of the success we've had in our projects in Jersey City.
I want to toss that same question to Ed. I know you touched on this in your talk a little bit earlier, Ed, but we have some places in the Developer's Green Infrastructure Guide where we talk about anecdotally cost savings and return on investment. So Ed, can you kind of talk about where people can find that information in the guide?
Yeah, absolutely. So one of the chapters I mentioned up front was the benefits of green infrastructure chapter. So that chapter is really tailored to answer this question. It covers all of the intangible benefits that George just mentioned, as well as some of the more hard cost benefits to be made. So if you review that chapter, you'll see a number of studies referenced. You don't have to look too far outside of New Jersey. For instance, if you look at Philadelphia, has had a green infrastructure ordinance change like this adopted for about the last 10 years. And they regularly release financial package updates on how that's affecting the bottom line of the city, as well as different development sectors of people working within the city. And they're tracking the real estate values, and the real estate values in areas where green infrastructure has been implemented are getting notable percent increases when they go back on the market for resale. So there's a definite benefit to the aesthetic pluses that come with it. From a maintenance perspective, you have to keep in mind that these are visible systems. Everyone's required to maintain their current stormwater systems. It's just less noticeable if you forget to maintain your underground detention basin. If you forget to maintain your rain garden, it could start to look poor. But as George pointed out, there just has to be a mental shift to put maintenance onto landscape crews and educate landscape crews to be able to maintain that as part of the overall site landscape management strategy. So it's less about people coming in and looking at pipes or opening inspection ports to look at underground stone beds, and it's more training our landscape contractor community to be able to recognize typical rain garden plantings and how frequently to come out and prune, mow, or maintain them.
Yes, there are lots of questions about maintenance. And Ed, can you talk a
Yes.
little bit about, maybe this is partly for Jim too, the Best Management Practices Manual itself has detailed information about maintenance for each of the BMPs, does it not? Or are there other resources that you go to for not only maintenance requirement information, but also maintenance training?
Let me just take a quick shot at what we have on our website. Yeah, within each BMP, it addresses the maintenance requirements that have to be completed. And also, the department updated its webpage to include specific information and downloadable material for each BMP that's out there. Basically, it would give an owner spreadsheets, information, things that they can use to document their inspections, document any maintenance that's been completed. So, you know, the BMP manual in combination with the maintenance webpage includes plenty of information that can be and should be utilized by BMP owners.
Yeah, so to add to that, Louise, George, do you want to jump in?
No, you go first, Ed. I'll go after you.
All right. So I would go first. You know, the BMP manual is great for frequency and types of inspections, how frequently to do them, etc. You know, what I want to emphasize is that the people you're now handing that maintenance manual to is where the big shift is going to be. You want to make sure you're finding landscape maintenance crews who understand the difference between a perennial, a grass, and a weed. And that's going to require a little bit of training. You know, I think we'll see a lot of training seminars, both from DEP and other local municipalities over the next year before this operative date about maintenance and updating our landscape contracting community on these new practices and what they should be doing. Speaking from experience in our work in Philadelphia, there was a knowledge gap for the first year after the rules down here went into effect. And I fully anticipate that knowledge gap is there now. And you know, I applaud DEP for getting ahead of that by having the 1 year operative delay. And I think it's incumbent upon all of us on this call and the professional community to get further webinars like this out there with where people can find this information and to offer training.
Okay. So I guess I should have gone first because you said most of what I wanted to say. But what I want to add to I want to just add to what Ed said a little bit. You know, when you build a building, your design team typically does the construction documents, which include details, construction details, and scopes of work. And what needs to happen is when you transition into the maintenance phase of a project, you need to have those details on a scope of work. And in the case of your landscape maintenance crew, you know, they need to get a drawing that shows them where all the green infrastructure installations have been placed, what the detail is, what went into the construction of those details, because there's a lot going on below the surface. What Ed said, what kind of plants are being put in there, and how they need to be taken care of and replaced at when they're at the end of their useful life. So it's all about locations. You know, where are the green infrastructure installations? How were they built? What needs to be done to maintain them? You know, routinely, and then at the replacement at the end of the useful life of the various components. So it's really like building a building all over again. Unless the landscape people understand, where it is, how it was built, how you maintain it, short term and long term, they don't have the information they need to properly quote the cost of the landscape maintenance contract. So it's always about the quality of the details and the quality of the scopes of work equals the quality of the bid that you get to do the work. So it's important you do that.
Thanks, George. Here's a question for Jim, DEP. How will the new requirements be applied to agriculture development, if at all?
Well, the application is still the same with respect to the modification on water quality. So if it's not a major development that is ongoing, then the rules don't apply. We have issues in New Jersey with a significant amount of runoff from agricultural locations. And what we do in those cases is work with the Department of Ag, the NRCS, in order to talk about and possibly get the farmer to implement some BMPs, such as the way they plant their crops, the direction the crops are planted, is their ability to put some type of swale or other type of BMP within the site. But if it's an agriculture location, if it's not a major development, the rules do not apply.
Okay, thanks. This, I think, is probably for Jeremy and or Ed. Could you provide examples of the types of technical constraints that may lead to a waiver or allow other types of BMPs to be utilized?
First, I'll start with the waiver process as outlined in the new rules is meant to be very onerous, and it's going to be very onerous. The DEP, as you know from experience of those of us that are in the land development world, is already very difficult on any kind of waiver or exception or deviation from standard practice. This is going to be especially true in this case. As far as what might trigger a waiver, I think it's going to be a very limited window. It's probably going to be related to sites that have really particularly bad soils, probably brownfield type of sites. Although even in those cases, there is generally a green infrastructure solution. So my advice would be to really look long and hard at different types of green infrastructure, using liners, using under drains, and things like that before you go through the waiver process. It's going to save yourself a lot of aggravation and time in doing that. But to answer the question, I think it'll probably be mostly brownfield type of sites where there's particular constraints.
Okay. Ed, did you want to add anything to that, or shall I move on?
No, I think Jeremy's right. I think the waiver process is going to be a case-by-case basis. It's tough to speculate at what may or may not trigger it because I really think it's going to depend on a specific site instance. I think where we have those hard environmental constraints, maybe having infiltration, mobilizing contaminants in soils, etc. Those are the type of things that would start the conversation off on the right foot. But as Jeremy alluded to, there's solutions to make the green infrastructure BMPs work in those instances with liners, under drains, and other techniques. So I think it's got to be a combination of several difficult factors that would come up.
Okay. Another question for engineers, I believe. For sites with a large profile of fill, how do you characterize the infiltration properties for the variable fill as an accepting soil body under the design requirements of a green infrastructure solution?
You want me to take that?
Yep.
Yeah, you want to start off?
So the key is to look at all the different soil horizons and find the most restrictive layer. That is much more challenging in a fill situation because the conditions can be so variable. But you still have to look at the general characteristics of the material and then figure out where the controlling horizon is from the surface down to the seasonal high water table. And that's the layer you test. In a site like that with highly variable conditions, it is going to yield having to do more testing. There is some ability to do less testing under the Chapter 12 that's currently proposed in the BMP manual. That's the replacement for Appendix A. But in highly variable soils, you're probably not going to be able to take advantage of that. So it is going to mean more testing. What we do in practice, we'll have several samples pulled for testing when we're out in a site like that. And then we'll kind of in the lab figure out which ones we're going to more fully run to figure out the most restrictive horizon. The other thing to think about, if it is a relatively thin horizon, is just to remove it altogether, and do a soil replacement under the BMP.
So Louise, we have about 5 minutes left. How about 1 or 2 more questions?
Okay. Here's a question about wet ponds. Where wet ponds directly interface with the groundwater table, can the groundwater recharge requirement be satisfied since you are effectively recharging the groundwater?
It's an interesting question, but typically no, the DEP would not accept that. But I can defer to Jim if he has any different insight. But typically I would line the wet ponds, even if we're into the groundwater table, just to make sure that we're not going to be susceptible to changes in the groundwater. If we have a drought year or something like that, all of a sudden we have the pond running dry.
Yeah, I would agree with that. Plus, if you're having, if you're in the groundwater table, I mean, you may have groundwater infiltrating into your wet pond. So you have to keep that in consideration when you're sizing your wet pond for your attenuation and detention. So, we normally don't see the wet ponds in areas where there's infiltration. If that is done, they're usually lined or a clay layer is put in place.
Okay, here's I guess a last question since maybe it's the second to last question. I'll let Candace make that call. How will these rules be applied in tight urban redevelopment sites consisting of existing impervious surfaces? Often underground detention is used. Will this be permitted?
Sure. I mean, you can in tight urban areas, which is where we want the possibility of the use of the green infrastructure, as George was mentioning. So the other thing is, depending upon how much work is done, I mean, you have the option for green roofs. You can do subsurface infiltration or detention if possible, but depending upon the water table.
And there's a couple of places in the guide where we talk about urban areas. So you want to take that one, Ed?
Yeah, I was going to say, some of these questions are good ones to do a test run through the decision-making tool on, because there's a couple of branches in that decision-making tree that specifically address an urban redevelopment area or an area where you can verify no infiltration, and it will lead you to the recommended BMPs from which tables in 5.1, 5.2, and 5.3 would be appropriate. So I would give our tool a test drive for some of these questions and see where it leads you.
Okay. Here's one maybe last question.
The last one.
Okay. Will DEP be open to considering innovative technologies that have demonstrated and will guarantee performance for 10 years from date of installation, improvement of native soil infiltration rates of 5 to 10 times? That's a very specific question, but the broader one being consideration of innovative technologies that have passed a certain quality test.
Well, I'm not sure what innovative technologies, but the rules still allow alternate designs and alternate technologies, provided that they essentially meet the GI standard where necessary or meet the same design standard. So the rule doesn't take away anything in terms of the ability to provide an alternate method or an alternate way to meet the standards. So that can still be done, But when you have an alternative design that's not consistent with the BMP, anything approved under the BMP and consistent with the design, you get the assumed removal rate. So if it's an alternate design, that information does have to be submitted to the DEP for review.
Okay.
All right. So thanks for giving us those questions, Louise. So at this time, this concludes our panel session. I want to thank all of you for tuning in today. So immediately following this webinar, you will receive a survey in your email. We'd love to hear your feedback on the developer's guide, the content that you heard today, and the overall webinar. So please fill that out if you have a few minutes, and stay safe and take care. Thanks, everyone. Bye.